All right, so if you're following along, page 189, and the first part, I'm pretty sure you've actually done this before. It says, let's start with something like that. Do you remember the good old days? Well, when you started these back in the good old days, we didn't call it simplifying, we called it reducing, right? So can someone tell me why this is not simplified already? Why is that not simplified? You can divide both top and bottom by something, right? And what is that something right here? Divide by 2 and divide by 2. Remember, you can do whatever you want to the top and bottom, divide by any number you want, as long as whatever you divide the top by, you divide the bottom by. So in this case, we're going to divide top and bottom both by 2. On top, 2 divided by 2 is 1. 4 divided by 2 is 2. So 2/4, 1/2, same thing. And when you got good at it, you just said 2 goes in there one time, 2 goes in there twice, right? Didn't you do that? What if I have something like 2/7? Simplify it. Simplify it. Simplify it. You can't. Why not? Because there's nothing that goes into both 2 and 7. They're actually both prime. But they don't need to be prime. What if I have something like 3 and 14? Let's not even make it 3. Let's make it 9 and 14. Neither one of those is prime, right? 9 is 3 and 3. 14 is 2 times 7. So neither one is prime, but the thing is they don't have any factor in common, right? So that's what we're looking for over here. We're looking for a common factor. They might not always have a common factor. And if they don't have a common factor, then they're already reduced the way they are. They're already simplified. Might have to simplify it, they might already be simplified. So that's today's lesson, basically. We're going to be reducing fractions or simplifying. So we're going to be looking for something that's common to both the top and the bottom. In this case, 35, 42, what's common to both?
7.
You can just say it. You don't have to raise your hand. 7. So we're going to divide top and bottom by 7. What is 35 divided by 7? Say it. 5. And on bottom, 42 divided by 7. 6. Now, what you have left, 5/6. Do those have anything in common, 5 and 6? No. So you simplify. That's as far as you can go, right? That's not too bad so far. You remember doing this? Now, let's add a couple of letters and a negative sign. And the directions are still simplify. Before I simplify that, I can't tell. Before I simplify that, let me ask you this. What is 2 over 2, what does that simplify? 1 over 1, or just 1? What is 5 over 5? What is 10 over 10? What is 17 over 17? What is 186 over 186? Do you see a pattern there? The pattern is anything over itself, anything over itself, anything over itself, anything over itself is equal to 1. So anything over itself is 1. But then everyone always gets their undies in a bundle. Everyone gets their undies in a bundle when you switch it to something like x over x. It's just 1. What is anything over itself? 1. And what is y over y? And what is ABC over ABC? Anything over itself is just 1, right? So then when we get over here, what is anything over itself? 1. They cancel each other out, it's just 1. So those cancel and give us 1. The y can't do anything with because there aren't any other y's. What about the 4 and the 10? Simplify? What can you divide both by? Divide by 2, divide by 2, and what does that give us? On top, what is negative 4 divided by 2? Right? On bottom, what is 10 divided by 2? And then we said there's nothing else you can do with that y because there's none in the bottom. So it would simplify to negative 2y over 5, right? Does that make sense? Does that make sense? Yes.
So instead of like writing a 1, you just cancel it out?
You can write a 1 if you want. You can write a 1, but if you do the 1, if you do a 1 there, what you're really going to have is negative 2 times 1. What is negative 2 times 1? Yes, negative 2 over y. Sorry, negative 2 times y over 5. Right? So usually, if it's the only thing there, you have to write the 1, but if there's other stuff there, then you don't have to. Are we good so far? Holy cow, I just turned the page. What is this? Oh my. Then they get into stuff like this. Now, before you tell me anything, do you remember the definition of x squared? What is x squared? Isn't that x times x? Yes? And on top, x to the 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. You know what we just did over here with the x over x? We crossed it off. We canceled it out, right? 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 So guess what we're going to do with these x's over here? Cancel them out. Cancel it out. Here's another pair. What are we going to do with those? Cancel them out. Now, I don't have anything left in the bottom to keep canceling. So what do I have left if I simplify that? Say it. X to the 7th power, right? So this one simplifies x to the 7th power. What if I have x to the 6th over x to the 2nd? Same kind of thing. On bottom, x squared is x times x. On top, x to the 6th really means it's x times x times x, x, and another one, and another one. Whew. So what can you do to those? There's a pair. There's a pair. What do you have left there?
X to the fourth power.
X to the fourth power. X to the fourth power. Anybody see a pattern there? Because this is going to get real old writing all those out. Especially, what if I have a to the 35th over a to the 19th? I'm not writing out 35 A's. Are you? Yes. Subtract them. There's a rule there in one of those gray boxes where they use all those letters that don't make any sense. There's a rule there that says, oh yeah, there's a rule there that says, instead of writing all those out, look, 6 take away 2 is 4. 9 take away 2 is 7. The rule says all you have to do is subtract those exponents, thankfully. So what is 35 take away 19?
16.
So I have a to the 16th. And that's it. That's all you have to do is subtract them, thankfully. So if I have m to the 7th, m to the 2nd, what does that give me? M to the 5th. And you don't have any work to show. Except, do you notice all the ones we did so far, the bigger, I have a biggest exponent on top. The bigger exponent is on top. The bigger is on top. The bigger is on top. Well, what happens if I have x to the 2nd, x to the 7th on the bottom? Well, if you think about that for a minute, x to the 2nd is this. X to the 7th, 2, 3, 4, 5, 6, 7. Those would cancel, and those would cancel. What do you have left here? To the 5. And where is it? In the top or the bottom? It's in the bottom. And what do you put on the top then? Just a 1. When everything cancels, you know, like over here, it canceled 2 divided by 2, it's just 1, right? If I had 7 over 14, it's just a 1. So you put the 1 on top. And what I always tell my students is, when we're doing this, you look to see wherever the biggest exponent is. The biggest exponent is on top, then it's your answer has the exponent on top. If the biggest exponent is on the bottom, then it goes on the bottom in your answer. Wherever the biggest exponent is, that's where it goes after you subtract. So if you have x to the 3rd over x to the 10th, where is the bigger exponent? On the bottom, so that's where it's going to go, on the bottom. Right? Does that make sense? So then we can reduce stuff like 35, oh, I'm not going to be able to remember this. 35 x to the 3rd y z to the 6th. 35 x to the 3rd y z to the 6th. And on the bottom, 56 x to the 6th y z. 56 x to the 6th y z. By the way, if there's no exponent up there, what do you assume is the exponent? Uno. Uno. So if you don't remember that, you could probably just put one there to remind yourself. And you look at all those numbers and all those letters, one at a time. One at a time. Do the 35 over 56 first. What goes into 35 and 56? 7. Divide by 7. Divide by 7. What does that give? 35 divided by 7 is 5 over 8, right? 5 times 7 is 35. 8 times 7 is 56. So we'll start with that. 5 over 8. That takes care of the number part. What about the x's? Well, we just did the x things over here, right? You just subtract, and wherever the bigger one is, that's where it goes in your answer. So right here, I have a 6 and a 3 on my x's. What's 6 take away 3? Right, 3. And it's bigger on the bottom, so x third on the bottom. Here I have y over y. Y over y is just 1 because anything over itself is 1. And here, z to the 6th, and what did we say is the exponent here? It's not 0. A bunch of you thought it was 0 on the quiz. It's a 1. 6 take away 1 is? And where is the bigger one? On top. So z to the 5th on top. Does that make sense? Does that make sense? Do you have questions? Do you think we're good? Do you think we're good? Do you think we're good? Oh, today's Tuesday, right? Do you think we're good? Are we good? Ugh, I'm on the wrong page. Oh, that's because I'm looking at the wrong class, right? So I'm on page 192. 192. One ninety two. How about right here? And I have WE 1, 2. I don't know what I have. How about 1 to 20? 1 to 20. How about 1 to 20? How about 1 to 20 and we'll call it a day. Yes? Yes, sir.
What if it's like, what if it is the same, like exponent and the same one?
Oh, good question. Good question. Hold up a minute. Thank you for asking that. What if it's the same? What if the exponent is the same? Excellent question. Well, we need to go back to what we were just talking about. And actually, I can explain it 2 ways. You know what you told me right here? What is anything over itself? 2 over 2 is? 5 over 5 is? 186 over 186. I can't hear you. I can't hear you. 186 over 186 is 1. What's x over x? What's x over x? I can't hear you.
1.
What's y over y? What's ABC over ABC? So you are telling me without a doubt anything over itself is 1. Anything over itself is, I can't hear you. Anything over itself is, I'm old, I'm hard of hearing. Anything over itself is,
1.
we want Mrs. Fisher in the next room. Anything over itself is,
1.
good. So now, to his question, what if it's the same exponent? What did you just tell me? Anything over itself is 1. Now, I want you to watch this though, because it's kind of cool. What is m to the 3rd? Remember what we just did? M times M times M? That's M to the third. What is M to the third? Cancel, cancel, cancel. What does that all equal? 1. And here's the cool part. What did you just tell me to do with these exponents? It's the S word. Subtract them. You told me to subtract those. So guess what? We're going to subtract those. What is 3 take away 3? 0. So I get M to the 0. This, but what is that equal to? 1. And here's what I forgot to tell you. Anything to the 0 power, it's always equal to 1. Because anything over itself is 1. 3 take away 3 is 0. Anything over itself is 1. And if those exponents are the same, 3 take away 3 is 0. But anything to the 0 power is 1. Anything to the 0 power is 1. Does that make sense? Sort of? Good question. Thank you. Does that answer it? Okay. Anybody else with questions? Anyone? Anyone? Questions?